Why are male parasites in such a rush? We'll talk about that later. But first, let me ask you a question.
Do you ever feel like you're running and you never get anywhere? Trust us, you're not the only one. In fact, there are many different organisms that go through the same process. We know that organisms need to adapt to their environment and surroundings in order to survive. Sometimes, interactions between two species are the forces that drive adaptation between them because both species are trying to survive and reproduce. This is called coevolution, and it can often be seen in natural environments. Sometimes, the organisms have conflicting motives, like in the interaction between a parasite and its host, where both organisms must adapt to the defenses or attacks of the other in order to survive. As told in the original paper proposing the idea of Red Queen dynamics, what one species gains, the other loses to the same extent. This idea comes from Lewis Carroll's Through the Looking Glass. The Red Queen was always running just to try and stay in the same place, which is exactly what is happening with the parasites and their host from an evolutionary perspective. While our parasites and their host aren't literally running, biologically speaking, they must keep adapting to each other in order to maintain their relative fitness. In general, Red Queen dynamics result in fluctuating patterns that look like this. Ta-da! Because the species with the beneficial adaptation will increase in population size as the other species decreases in population size until that species develops a beneficial mutation that will improve their survival. A newly studied example of this Red Queen dynamic is the relationship between the malaria parasite and its host. Due to the coevolutionary dynamics between this parasite and its host, the parasite undergoes sex-biased selection.
Well, gee, what's that?
Sex-biased selection refers to selection on sex-biased genes, which are genes that are only expressed in one sex. Sex-biased genes evolve more rapidly, especially when they affect the ability of the organism to produce offspring. Okay, now that we know what sex-biased selection is, we can see what it has to do with Red Queen dynamics in Plasmodium, a parasite that causes malaria.
As a parasite evolves to become more virulent, its host evolves to fight against the parasite, causing a continuous cycle of population increase and decrease for both species. Neither the host nor the parasite gains a competitive advantage high enough to completely eliminate the other. Scientists have found that male parasite proteins trigger more immune responses than female proteins, so the male parasites are more likely to be attacked by the immune system than female parasites. This sex-biased natural selection has pressured male Plasmodium parasites to evolve faster than females in order to prevent themselves from being driven to extinction as the immune system targets them.
This is a great example of Red Queen dynamics!
The researchers found that Plasmodium parasites exhibit phenotypic plasticity, which means that they can change their phenotype in a changing environment. In a situation like this, where there are pressures selecting against male parasites, they are able to alter their sex ratios and produce more males to make up for the loss of those targeted by the immune system. By increasing male gametes compared to female gametes, the males behave as a larger population. This means that beneficial mutations can fix faster in the population and deleterious mutations can disappear faster, once again allowing these male parasites to invade the immune system and reproduce. Each of these graphs show genes that were determined to be expressed only in males or only in females based on comparisons between different but closely related species of Plasmodium. The y-axis represents the ratio of non-synonymous to synonymous mutations, or we can just say rates of evolution. You can see from these graphs that genes expressed only in males are evolving at a faster rate than those expressed only in females.
So, what does this have to do with Red Queen dynamics?
All of this talk about sex-biased genes and Plasmodium parasites really just boils down to basic Red Queen dynamics. Neither the Plasmodium parasites nor the hosts have successfully caused the other to go extinct. They'll probably always be running just to stay in the same place. Here are the main points we learned today. Coevolution is a process that occurs when interaction between two species causes them to adapt in different ways. The Red Queen effect is just one form of coevolution, often seen in host-parasite interactions, where host and parasite populations evolve in order to increase their chances of survival. We discussed one specific scenario of Red Queen dynamics, but there are many others. The findings of this study are significant because they show us an evolutionary method that parasites use to continue to survive and reproduce. This knowledge has some sweet real-life applications. To design drugs that target harmful parasites more effectively and eliminate them from hosts, we should design drugs that target the slower evolving sex, or both sexes, so that beneficial resistance mutations cannot arise as quickly, and the drugs can eliminate the parasites before they can pass on these mutations. Studying evolutionary methods and patterns allows us to not only learn more about natural processes, but also to utilize our knowledge and apply it to the greater good.
Because knowledge is power.